Hello, folks. Gonna wait another 2-3 minutes before starting. In the meantime, if you want to fill in the doc with your name and affiliation, please. Thanks much. Mark, are you okay with 10 minutes, or do you want more? Or
Look, if push come to shove, the verifier work, it's basically a document. People can comment offline. We can continue that discussion. So will we get to it? We get to it.
okay.
I mean, otherwise, I'll just ask people to continue working on the documents and the comments offline. I've done some extensive work on it over the week to list assets and roles with respect to assets and expectations, and I cleaned up terminology a whole lot. Doesn't mean it's perfect, but that's the kind of work that I feel it's kind of almost inefficient to have everyone on the team going over every word. But I would. Yeah, if we have 10 minutes, we'll make some progress. We'll make the most progress if people work on this offline.
Okay. So we can keep Marcus for the whole half an hour, I would say, if you agree with the 10 minutes. I will try to keep the chair updates
Yeah,
short.
let's get all the other work ahead of us or in front of us done first.
Okay, I think we can start. The numbers are good. Welcome, everyone, to this CCC Attestation Meeting. We have a quite packed agenda today with Usama, Marcus, and Mark sharing the stage. I wanted to start with a very quick update from the chairs. We have worked on the travel expenses document, which I've linked in the chat. We have discussed this already last time, but there was a point that was raised about the feedback time. I think Usama raised this point, which was quite critical, and we hadn't thought about this. And now, point 4 in the 5 steps for getting the travel approval has a time indication. We say we want to be able to process within a few days, 2-3 days from when the request is done. But at most we will take a couple of weeks to take a decision. I think the steps are quite clear and should be pretty easy to do the request. We have a very limited budget of $2,000, as we already said last time, and we have decided to split it into 4 chunks, $500 each. So you can apply for at maximum $500 per trip or per whatever. The reason is that you are requesting the money. Please have a look, and if you have further questions, raise them on the list or on the chat. Usama, you have your hand raised.
Yeah, thank you very much, Thomas and other chairs, for taking care of the request. That would be 2 to 3 days would be really perfect. Even if that's 2 weeks, that's perfectly fine for me. I understand you guys are busy. One other thing that I would like to raise is it kind of contradicts the CCC policy in a sense. There is, or I'm not aware of any limitation of the budget. Either it is approved or rejected. So is this 500 inconsistent with the CCC policy? So I'm not saying to raise it a lot, but at least something that with which we can attend some event within EU, like something like 700, 750. It's something that's maybe reconsidering.
I think, I understand what you're saying, and we know that this won't cover the full cost, except, very, very rare things where you're basically the conference is within reach. But we have this 2,000, right, that we need to split. And if we do the 700, then we wouldn't split evenly. And that would be a problem. And also we would have less people to give it to. We prefer to have, the ability to give the split the budget among, 4 different individuals, say, rather than less than 3. And even if that means less money for each of them, I think that's the balance that we found, and I don't see where this contradicts the CCC policy. That doesn't seem like.
I mean, there is no limit set over by, or I'm at least not aware of any such limit across CCC. So either it's approved or rejected. There is no limitation on the budget. So there is only a binary thing like,
Right.
okay, we approve and this cost estimate that you provide, but there is no pre-limitation, let's say that, okay, so we will only give you 500 at max and whatever the let's say the total amount is. That's what I mean by contradicting.
Okay. Before, when the budget was 10,000, I think that made total sense because all the things are within budget, right? Unless you're going to the moon. Now that the budget is so limited, even if you want to do transatlantic, I think something like that wouldn't cover completely your costs. So we have to take other criteria into consideration. Greg, please go ahead.
Yeah, I was just gonna say, I hear you, Salman. Those are very real concerns. Part of the way I think of this is I don't use this as cast in stone and forever. I think this is a learning process for us as a group. And so I view this as something where periodically, every 6 months, once a year, whatever, we as a group or we as chairs will look back and say, how well did this work out? If it turns out like the 500 ain't working great, maybe we're not dispersing the entire amount every year or something, then we can, discuss and tweaking it. So I would keep that in mind as you think about it.
So my concern, just to be clear, is, I mean, it's kind of disappointing to me that it's even worse than what we had before. So CCC was at least able to give me something like 2,000 euro for traveling to Canada for IETF meeting. I think it was 119 or something like that. So now it's $500 only. So that's the thing that I'm raising. It's even worse.
So sorry, I just joined the meeting. I was late, but I'm not sure that anything has really regressed here, right? Like this, if you were able to get money directly from the TAC, then whatever process that went through probably still exists. This is a budget that's given directly to the SIG that we've never exercised before, I think is the case. Correct me if I'm wrong.
Okay, if that's the case, I'm fine. So
Like
thanks.
this is all in addition to what we've done in the past.
Okay, right. Thanks for clarification. It's all fine.
And anybody, like other chairs or whoever, correct me if I'm wrong.
No, you're completely right. Yes. And also, Usama, we cannot, spend all the money in one block just for you, right?
Yeah. That's fine. I mean,
we try to make it a bit fairer to others that might want to access the budget. That's it.
Sure. I think the point that Keith make is perfectly fine. I was just thinking that probably the TAC is gonna say that, okay, so you have that budget, don't come to us again. So if that's the case, I'm perfectly fine.
It's my understanding that we've had this budget all along and we just didn't know it. So like if they were going to say that, they probably would have said that when you went to them before.
Okay, perfect. Thanks a lot.
Cool. So keep your requests coming. But let's move on because we are packed, as we said before. So, Usama, do you want to take the stage for 8 to 10 minutes?
Yeah, thanks. So I will just quickly share. Okay. So I hope you see the screen now.
So do you
Slides.
want to have discussion at the end or while you speak? Should we speak?
No, I'm perfectly fine with during the discussion. That's really the purpose. So I just want to clarify a couple of points. So please feel free to speak up when I'm speaking. Okay, so without any further delay, so we have another author edit in the meantime since last presentation. Mariam from Aalto University replicated what I had done in my formal model, came up with exactly same results, give us kind of more confidence that identity crisis actually exists. So this is the recap of the protocol in the IETF draft for Saudi TLS attestation, that it's intra, just as a recap with the client hello. In addition to the TLS, there is attestation nonce, which is part of the evidence. And that part, that evidence is then self-signed and put into the certificate. However, for certificate verify, it provides the proof of possession of this key and not the identity key. That's the key point. And to clarify what we were discussing along or the points that Ned and Greg raised, so I've tried to clarify it hopefully in a better picture now, which is saying what is the problem with the remote attestation only solution, namely signing via this key only, is that if I provide this kind of remote attestation certificate, what would an average cloud customer think about this, or would he or she be happy with this or not? And we believe this answer is no, because the client would actually like to connect to this and not see some measurements only. So we are not saying that this is useless. Of course, the combination of the two things, namely this certificate and the identity certificate combined together, would be stronger than having either of those, meaning only TLS, standard TLS, or this remote attestation only based solution. And that's the argument that we are making, that instead of connecting to this data center, it might connect to a completely different data center, which it didn't even expect to connect to. It's still a TE, that's fine. But the problem is that it could be under control of anyone, right? And for that, we propose a few solutions, namely, this I already mentioned. So we propose to augment both the Web PKI cert as well as the remote attestation cert, combined together, providing both guarantees. What is the identity and what is the computing environment integrity status? And as I said, the challenge is that the certificate verify message is not extensible under TLS 84, the internet draft, the RFC 8446. And the proposed solution that we propose are, number one, of course, make it extensible in order to provide proof of possession of both keys, namely the identity key and the remote attestation key. Or the second option is to allow multiple certificate verify messages. That is, the TLS protocol remains the same. The only change is that we can have multiple of those messages, and it can be done either as part of the handshake message itself, or it can be done as after the handshake, which is a new draft that a few of us in the SIG have, which is with the post handshake solution, and it uses the RFC 9261 in order to do that. I will not go to the details, so that's the initial draft that we are still working on. The next solution is, or proposed solution, of course, we have not verified any of those. It's just think of those as possible or proposed solutions that might or might not fix the problem. Hopefully the first two definitely will, but we need to verify, of course, it might introduce new problems in the state machine. Question?
So, if I may, Usama,
Yes, yes,
are
please.
you saying in the first bullet that there are now 2 certificates involved in the RATLS protocol?
I wouldn't say RATLS protocol. I would say in general that the attested TLS protocol, any attested TLS protocol, should rather have 2 certificates rather than just one.
Okay. Where I'm going with that, and I don't want to rat hole on it just yet, is when we look at the trustworthy workload identity, which is the other effort that we have underway, we issue certificates to workloads, hopefully suitable for TLS, as a as a result of them attesting, and then we hope that we will somehow enforce that the workload must be in the in a state where it can fend for itself and prove its own isolation, etc. As part of, right? So in that case, you only have one certificate, and that certificate is going to be sufficient for TLS effectively as is. So again, I am probably talking out of my butt right now, so I don't want to.
Okay, I will come to that point exactly in the next slide. So let's wait for
It's
a
just
few
changing
seconds.
protocols, changing TLS is super expensive. Keith has his hand up.
Keith, you wanna talk?
Slightly separate topic, so finish this thought. Anything more on that?
Just want to
There's
say
a-
that
there's
I think
a-
it's
there's
like,
a-
but you guys-
I'm
There's
hearing
an
a lot
echo.
of
I can't
echo.
understand anything.
Sorry about that. I was saying, finish your thought. I have a slightly separate topic.
Okay, so this solution, the third solution, actually is exactly doing that, which is saying we don't need any change in the TLS protocol. And it's defining a new signature algorithm that is a concatenation of the 2 signature messages. Probably this might work. We have no cryptographers in the team, but we are looking into this. Fourth solution is saying identity key, the long-term key signs the certificate verify message as in the standard TLS. So it proceeds like that. And the ephemeral key only signs the self-signed certificate, and which contains the channel binder as part of the evidence itself. So this might fix the problem that we have.
By the way, as a precondition to things being deployable, we'll need to, and this is going to be a real nasty one. So just to put a pin in it for now, we need to figure out reverse proxies, load balancers, and whatnot. So channel binding is what killed the original channel binding. Reverse proxies killed channel binding 7 years. This is when Google took it out of Chrome for that reason. So just let's be very careful that we don't repeat the mistakes.
Yeah, but I think we need some channel binding to avoid the relay attack. But anyway, so I will kind of describe why this is a problem in case of diversion within the CSP. So the previous one was across the CSP, it could go to any machine in the world. And now the CSP might have one machine which is compromised. Compromised meaning that its attestation key has been compromised. And this is the attester side acting as the server. And there are a number of attacks which are possible, like foreshadow. And now with this key, the CSP can actually sign any required measurements, any required identities, whatever is required, it can provide that certificate. And that's what I actually mean by saying that it's now not a replica of VM1. It's actually a different VM which is created by the CSP in order to actually get the secrets from the client. And currently we do not have any solution for this. So this is one of the open problems. Another open problem that I want to describe is
Sorry, can I?
Real quick, can you go back to that one?
sure,
Yeah.
sure.
Go ahead, Keith.
What are you calling out as, like, what's the difference between diverting to VM2 and having it compromised versus just compromising VM1? Like, what is the difference here if they have the same, like, code identity?
They do not have the same code identity, meaning that VM1 is not the same as VM2, because if we have that replica, the adversary doesn't gain anything. I mean, the attack is very small if I compromise that specific machine versus compromising any openly any machine. So that's where the real point is, that it's not that specific machine on which it was expected to run, or actually you have no guarantee. The protocol provides you no guarantee at all in which machine it's running. It provides you proof of possession of this specific key, which both of the enclaves have. Right, so it's EK1 and EK2, but
I
it's
see. So what you're calling out here is really that the client does not get to see what machine it's running on.
right,
Because,
absolutely.
like, as far as like the virtual machine itself here, like it could very well have not existed, and VM2 is the only one that exists. It's not really diverting; it's just an attack. So I think you're
Diverting,
saying that you would like to see more binding to the physical machine.
right, that's correct. So that it cannot be
Why?
diverted. Diversion is in the, sorry, let me just add one thing. So this is because of the reason that if we have a strong binding to this from the client perspective, it would not be able to divert this to, diversion is in the sense that instead of connecting to VM, it's connecting to, or CPU 1 or platform 1, it's connecting to rather to a
So how
platform
you
2.
handle load balancers?
Yeah.
You have to answer this question, because that's the primary way by which you connect to any compute.
I
the world.
asked exactly, so a simple answer to this is, I asked exactly this question, I think at least 6 months back. Thomas may correct me if I'm wrong. And the answers from the editors was, IETF doesn't care about the load balancers. So yeah,
Well, if
that's
IETF doesn't care
that's
about
a
things
weird
being deployable,
reply.
that's
Yeah.
not, like, we can't go with that.
yeah. So
This is not optional to solve. Like,
So have you considered, I mean, solutions like OSCORE that are trying to take into account load balancers? Maybe there's a requirement on the protocols outside, right? So
load balancers are not in the
sorry,
picture.
Fritz, you're correct, but I've never seen an IETF person saying we do not care about load balancers because middle boxes are a funny word. You just have to tell any IETF the term middle box and they laugh. So that's obviously a point of discussion.
Yeah, it's just out of scope of every working group, and everyone considers that it's someone else's problem.
yeah, but we need to make it our problem.
Yeah,
Sure,
first of all, that is weird to say. So just come to core and talk to core people. They understand, I want to say, that end-to-end is cut, and you still need the hyper end-to-end in the end. And so, yeah, I'm a little bit confused by that statement. But in the end, yeah, you are correct. There are
just
no
to
solutions out there that
so
address this problem.
just to clarify, Yaron made that statement. So feel free to argue with him. So that's what I got, and I didn't explore load balancers further. But anyway, if the solution, let's say, exists, I will be happy to look into it if you can send me a pointer to that.
Usama, just a time check. You are a few minutes over already.
Okay. So
Marcus, there was
I will finish here. Yeah.
in 4 minutes. There's a hard stop.
Yeah.
No, I didn't want to stop you right now, right? I just saying, we need 30 minutes for Marcus, so you have
Okay.
3 minutes if you want to.
So how many minutes I have? Okay,
3.
3 minutes. Okay, thank you. So let me share again then. Okay, so yes, this is the final slide. Basically, what it's saying is the other problem, which is a kind of a chicken and egg problem, that how do we get this identity and long-term key into that workload? And one simple answer which is given is that, okay, do attestation, right? But I do attestation not with this identity. I need to do attestation with the measurements, right? So I do first attestation with the measurements, which are the initial and the extended measurements. And only then I can get some secrets. But how does it now decrypt this workload in order to get started? It needs that key. And it's one thing is saying that, okay, so we do this when we have that identity. And the other thing is saying that, okay, we do based on the measurements and then we get the identity, and it's still suffering with the same problem, that where does the identity gets assigned to this specific workload? That's all I have. Yeah, if there are any questions, I am happy to answer. And I want to thank all the people who have so far contributed to this. We will present a TLS working group and WIMSI working group to see if there are any follow-ups or future directions specifically about the solutions that we are proposing, to see if we can make progress on that. Any comments or questions or thoughts? Okay, no, if not, then thanks a lot.
Well, there was
There
a
is a hand
question
raised.
from James.
Sure, go ahead.
So I'll just kind of like add in a little bit. So in terms of like the identity, can the identity be the measurements? Because the measurements actually determine the kind of like code, I mean the environment bus code that we are running in. And actually the measurements can also extend to things like, for example, instance type and workload configuration option. So all of this can be an identity, right? Like that defines the identity that I'm interested in.
So the very first point is that actually none of that, I mean, in the current existing solutions, not everything is measured. In the ideal solution, even if everything was measured, that would not constitute a solution of the problem, because I could still have one machine for which I have the key leaked, and then I can replicate what the desired measurements and all the identity fields were. Like the slide I had with the
No.
why
because
not?
the private or the enclave identity, basically the secret that is embedded into the silicon itself acts as part of the measurement. So if you compromise another key, yes, you can create a fake attestation report, but it will actually be a different identity, because the secret that is used to generate the attestation report itself is different. But yeah. Anyway, we can have this discussion maybe.
Yeah, sure.
Yeah.
Sure. Please feel free to write to me by email, so we will follow up. Thanks a lot.
Oh, thanks, Usama. Let's go to Marcus then.
Hello.
The stage is yours. Please
Thanks.
share whatever you have, and good luck.
Thanks. So hi, I'm Marcus from Agile Systems. I was invited here, so I'm not a regular in this group. I was invited here by Usama, who I had a chat on the Slack group with, and I was invited to present our attested TLS solution that we are using in several products by now, which is as far as I understand, and I'm not an expert in all the drafts that are going around, but I think it's similar to existing attested TLS proposals. The reason why we can go forward into production with it is because we basically control most of the stack and are more agile and don't need to standardize first. But I'm getting ahead of myself. Let me quickly share my slide deck. Sorry, I'm not doing this often on Zoom. I'm presenting the presenter view, right?
Yeah, we're seeing that.
Okay, let me try again.
No, it's fine, Mark.
No, it's okay. It's okay. It's great.
Oh, you're not seeing the overlay with the timer and so on.
No.
Okay, thanks a lot. Okay, so Agile Systems has a couple of products for confidential computing. I'm only going to talk about Contrast today. Contrast is our distribution for confidential containers. So some of you are aware of the project that tries to get confidential computing into Kubernetes in the sense that you have pods running in confidential VMs. There's an upstream project called Confidential Containers, which is built up on Kata containers to start confidential VMs, and then has a system called KBS, the Key Broker Service, which was renamed to Trusty. Maybe that is more familiar, which is supposed to verify evidence produced by the confidential containers. We are only using the Kata containers part to launch VMs and build the verifying stack ourselves. Maybe let me quickly show you a summary of how the system looks like. So we have usually a human operator or maybe some machine operator in a trusted environment, which is like out of scope of the attestation and so on. They have some set of measurements. So we have predefined virtual machines, which are then launching containers. Those are measured, reproducible. We go and launch a couple of pods. The first pod and the most important one is our coordinator. So the coordinator then verifies all the other. Sorry, this does not advance correctly. So, where was I? The coordinator verifies all of the pods, and the human operator verifies the coordinator. This works by setting a manifest to the coordinator that says what are you allowed to verify. So I will get to the roles in a second. Then the coordinator allows pods into the contrast deployment. This means they get an TLS certificate or an X509 certificate, which they can use to communicate with each other without needing to attest between themselves. So they only attest to the coordinator. There's a bit of additional stuff going on. So for actually launching containers, you need to verify more than just the VM measurements, because you need to also then have a sort of a runtime measurement that the container that you're starting is actually what you expect. And one of the nice features that we get by not using the KBS, but by having our own coordinator is we actually are able to give third parties access to running applications and at the same time excluding ourselves from access to the applications. Let me quickly say something about the roles that we have in our diagram there. So we have the human operator is in a secure environment, does the verification for the coordinator, and is also the verifier owner for the coordinator in the RFC 9334 sense, that it actually tells the coordinator how to verify. And at the end of the day, so when everything is set up, it gets a set of CA certificates, a root CA and mesh CA, which is not too important for this talk, which it can then use to communicate with the workloads directly without going over the coordinator. The coordinator runs in a TEE, so it's basically running in the same VM as the workloads are running in. It's just a special workload, so to say. It is the verifier for all the workload TEEs, which like I'm terming initializers here. It attests towards the operator. So when the operator contacts it, it presents evidence so that it can be verified. It acts as a certificate authority, which I mentioned before, so it distributes certs to the workloads and is also a key management service. And in the user workload, so in Kubernetes terms, this works as an init container, so a process that runs before your main workload, does some setup. In this case, it contacts the coordinator, requests some certs, requests some keys, and then lets the main process run. If you have any questions, like just shoot, but this was more for the context where we are using the attested TLS, which I'm getting to now. So in absence of a like standard way of conveying evidence in TLS, we came up with our own protocol because we had this problem that we want to establish a connection to a server, and server in this as you can also replace server with client here. It does not make a big difference. So you want to establish a connection somewhere. You want to prove that the thing you are connecting to is running in a TEE and is also running the workload that you expect it to run. So it has the appropriate like VM image measurements and so on. We also want that that we have an encrypted channel afterwards that is somehow tied to this evidence, so that we know that it is not relayed or something. And also, it's like not too important here, but what I also want to mention because of the identity crisis problem is so our assumption is that the workload is running in a moderately trusted or moderately untrusted environment. And everything that we input from the outside into the TEE is untrusted. So all the configuration that goes in is untrusted naturally. Other constraints which are like nice to have, but still important to us. Before we use an encrypted channel, we would like to verify the evidence that was used to establish it. I think this is kind of or one of the main differences between like our attested TLS and the KBS protocol of confidential containers. Which is first establishing a channel and then exchanging evidence over that channel. What we also did not want to do, we did not want to write like custom crypto or custom protocols as far as possible, because there's an obvious foot gun that we would like to avoid. Of course, we need to define a bit of protocol here, but we hope the surface is small enough. Then what we don't consider problems, and I mentioned this in my prelude, is we are basically not caring for interoperability right now or any standardization. So I would be happy to have a standard and just be able to use it like OpenSSL or Golang TLS implementation and do attestation there. However, that's like not on the table right now, and also I don't know for the foreseeable future. So we need something right now, and we are in the good position that we control like all. So both the client, so the client is our CLI, the coordinator is ours, and the initializer is ours. These are all built with the same libraries. I put middle boxes here, and it just turned out in the last couple of days that middle boxes sometimes are a problem. And as was mentioned in the last presentation, this is something that we want So right now it's not possible to do a TLS inspecting proxy or something in between the client, the CLI, and the coordinator. It's also a bit out of scope. We have some ideas for changing this, which will become apparent in a minute, I guess. So what did we want to do? So we decided, okay, there's TLS. We should be using TLS. This is kind of proven thing, and it seems like the right thing to do. We want to use ephemeral keys, so that are generated inside the TE, and that the workload can prove that it generated inside the TE. This gets us around the problem of all configuration that goes in from the outside is considered compromised. So how can we use TLS? So we need to find some extension points where we can actually fit our attestation data in. Our attestation data in that sense is we need to send a nonce from whoever requests an attestation to the attester, and we need to transfer evidence back to the verifier. Then ideally the TLS channel state would be somehow bound to that evidence. And we are kind of, because we are programming mostly in Golang, we want to be able to use the extension points that we identify through the hooks that are provided by the library. So let me get to the extension points. So I think like for proper TLS integration, this should all be like registered extensions and so on. But we saw some points where we could actually inject some information from the client to the server that can then be used to do the attestation handshake. So first of all, in X509, we can just put arbitrary certificate extensions. So this is good. We have at least a back channel for the full reports with measurements and so on. We can just put it into a certificate that we generate and self-sign. However, what we also heard before, like the messages before sending a certificate are somehow limited and in what you can transfer. We need to pass a nonce. So in the case from the client, so you need to do a client hello to the server. And then after the client hello, the server starts immediately sending the certificate back. So the nonce must be in the client hello somewhere. And there are only so many places to put it. We decided for the server name indication extension, which actually proves to be a pain point when looking at middle boxes. There are others that we could have used. For example, ALPN would have been an option if it were not taken by gRPC already, which we're also using. But yeah, so we wrote with server name indication. So this is what the final protocol looks like. Sorry, and for the for a testing server, the side channel that we're using is the certificate authorities field in the certificate request.
So, if I may.
Yeah, sure.
So we're looking into some of these issues in the trustworthy workload identity space, and so I guess we're going to have very close collaboration. But one of the key considerations is that not all workloads are going to go through attestation once in their lifetime. It is simply not deployable in a lot of cases. Some workloads live for just a few seconds. So if you think about having to put round trips to and from a verifier, like at least one, even if you don't do freshness, the verifier may just croak. It will not handle the load. Plus, you're adding network round trips that change latency of your think about Lambda. It shows up, does a few things, comes down. So it's more likely that we're going to go with an approach that your workload starts, it unseals from the platform a TLS certificate and a key that's used for TLS establishment. and then it just goes and uses the TLS. So if you're starting to bake freshness and attestation type of things into the TLS protocol itself, you are probably going to have a real issue with short-lived workloads. Like verifiers won't be able to handle the load, and customers will complain about how long the workload takes to execute. Plus, network cost of round trips, etc. So we need to figure out how to, and also some of your identities, like in this case, you're basically presenting a certificate and identity. We're looking, and I'm throwing out problems, not solutions, right? So like look at it in that space. Like I'm not telling you what you're doing is wrong, other than just like putting some additional requirements on you here. We need to figure out how to also work with like X509 and SVIDs from Spiffy. Like maybe both sides need to give a little bit, but ultimately, let's make sure that we don't accidentally introduce an architectural dependency that kills the ability to deploy successfully at scale.
So I'm not quite sure which kind of like architecture has the property that the workload is on a couple of seconds, because what I know from confidential containers concretely is that launching a VM until it is ready to start a container, we are on the order of like 15 seconds or something. Like
So
with
real
all
world
the
containers sometimes are very, very short-lived. Like very short-lived.
yes,
Lambdas are very short-lived. The only Hank, you have your hand up. Hank? Oh, had a hand up, it doesn't say anything. Sorry,
I'm so
Marcus,
sorry.
please
I was
continue.
talking to another mute here. Jesus, so many mutes. Yeah. So there's two examples for high scale thingies. For network function virtualization, of course, the small functions, very dedicated, scale up super fast, and then vanishes in an amount of minutes. And then, of course, you can call a Node.js microservice, for example, exactly that, a workload. And that can be very confidential, and those are really short-lived. These are seconds, and so because they scale on a microservice level that is very, very micro. So all these, in order to be considered workloads, I would say would be included here in the scope.
Yeah, I think what the difference is that we are not considering, so we're not doing a tested TLS for every connection that is going on inside our Kubernetes cluster. We're only attesting, in the best case, we're only attesting each container that starts once. And then the service mesh part kicks in. So where after attestation, there's an addition, so a certificate signed by our CA. And this is then used to establish these short-lived connections. So let's say you're running your Node.js. First, there's the initializer, which has nothing to do with Node.js, talks to the coordinator, gets its own certificate, where some of the claims are also included, but this is then more of a passport model thing, where we mint the certificate for the workload, and then the workload can use that to do the data plane connections to the other things, like the front-end to back-end connections or something. Is this does that make sense?
Yeah, I think if we had and again, this is just thinking out loud, if we have a way of obtaining a certificate and a private key for workload, and then sealing it to the platform such that when the same workload starts on the same hardware again, which is like in case of short-lived workloads, it's a very likely pattern that they'll just keep reoccurring. Right,
Yes.
then we can basically have, here's a provisioning step. This is where you can take your time, get your, credential, and then, but when you're actually here to do the work, it's right there for you. We may need to go with a model like this, right? And again, the key to doing something like this is not baking attestation into the TLS handshake, right? You need to, there are two phases.
So sorry, I don't get the last remark, because I can do the same thing that I'm doing right now, and I can also try to avoid doing the attestation handshake with my coordinator if I see secrets for myself before.
Yeah, that's probably
Correct?
how you do it. So yeah.
Yeah. Okay.
We're probably okay. I'm just
Got it.
saying, like, let's make sure we don't accidentally architecturally shoot ourselves in the foot.
Okay. So I think I have only one more slide. So which is like the verification goals that we wanted to have for this protocol, and why I think they are met. So remember, we wanted to bind both the evidence produced by the machine as well as the key material used for like by the peer. We wanted to bind both of these to the channel. And so what we get from the TLS handshake already is that the ephemeral key and certificate that are produced by the attesting side are already verified. So this is just part of TLS at the end of, I'm not sure where exactly it comes, but there's this signature over all the messages that are exchanged before, which is signed by the ephemeral key. So we have that bound. We know that the evidence is for this channel and not for like something stale, because we actually added the nonce. We have, sorry, I forgot to mention, maybe you saw it already here, but there's a thing that I call evidence parentheses nonce pub, which actually means this is a report generated. So let's say an S&P report, which includes both the nonce and the public key hashed together as the report data field. This is basically important for the point that I'm trying to make here. We have the nonce and the public key in the evidence. So the verifying side does the same. It takes the nonce, the public key, hashes them, and sees if the report data field matches. Now we know that the ephemeral private key is bound to the evidence. And the last thing that remains is we want to actually know that this private key is not leaked, is actually created inside the TE, and this is done by appraising all of the measurements, and the measurements tell us, okay, this is the VM image that we expect, and this is actually and we know because we wrote the code and compiled it that this is actually generating a key in memory and is not leaking it outside. Okay, that was my talk. Happy to answer more questions.
I have a side
Please
command
join
before
the TWI effort. Please join the TWI effort, the Trustworthy Workload Identity effort, because we will be creating impedance match between this and what Whimsy is doing, what Spiffy is doing. Like, what we cannot afford is a bifurcation where we'll have like competing and compatible approaches. So
Yeah,
that's my only comment.
Thanks for the invitation, I think. So I was about to ask the same thing because I saw that there's an ongoing effort. Happy to do so.
Can I bring in a quick comment before Thomas starts the discussion? So can you go back one slide? I just find it interesting. Like DOS is not, or denial of service is not really, I guess, in scope at all, right? We don't really care about that, but it just becomes with this protocol really easy to do, right? You just don't even need to do DDoS anymore. You just send lots of client hellos with nonce, and those each of them trigger basically an attestation. And that's going to be super expensive for your server to do, right? So I guess it's going to be interesting to see if how easily that breaks any server if you run it in real life. But
so we're running it in real life, but I think what you mean to say running it on the open internet, right?
Yeah, I mean, also running it where someone wants to DOS it. I mean, again, right, that's not something we necessarily care about because it doesn't break security per se, but it just makes it very interesting, like cross-disciplinary challenge, I guess, because now suddenly instead of doing needing a proper DDoS, you just, I don't know, instead of doing it distributedly, you just, I don't know, run 20 requests at the same time and your server immediately goes up in flames. So it seems magnitudes of order easier to do a DOS now. But yeah, no solution available, right? This will, I guess, apply to all attested TLS at some point because the attestation is just so expensive. But there's a lot of hands up, so I just wanted to bring this as comment
I
rather than
just
discussion.
wanted to one quick sentence because I actually like this is a valid remark, and doing all of this over the public internet would probably be like a very bad idea. This scheme is designed for data centers. So for data centers which you somewhat trust because you have a business relationship or something, but not as much as that you want to hand them your private keys. So I guess it's a trade-off. And I fully agree running this over public internet, and also for the use case that I mentioned before, where you want to allow people or third parties to verify what workloads are running. This is actually a challenge, yes. So now we have four hands raised. Sorry.
I go ahead. Thanks, Marcus, first of all, because it was a very interesting presentation. Yes. So these are all background checks, right? So my question would be, how many of this verification are you handling on a typical deployment? What is the pressure on the verifiers?
On the verifiers or on the attesters?
On the verifiers, right? Each
So-
each connection will spin off 2 verifications. Right. So how many?
Sorry. The mutual attestation is optional. So we usually have only attestation in one direction. And so the verifier, in our case, the coordinator, is a central component and thus like susceptible to overload. Yes, but I don't think only the verification is very compute intensive. From the initializers, as I said, we expect one attestation handshake per container start-stop lifecycle. So that probably, we did not get into the land where we actually need to scale up our coordinator, but we can. But this is still on the order of like dozens per minute max, right?
Okay. Okay, cool. Thanks.
Sorry, I don't know who was next. I don't see an order in
Mark is next, or Usama, I don't know.
Well, so what was I going to say? I'm gonna have to lower my hand for a second because I don't want.
So Usama, go ahead.
Okay, so very quick. In my understanding, basically what you are doing is like from the client side, you are using the SNI extension. From the server side, you're using the certificate request in order to put the both nonces.
Yes.
And with that, basically you are doing the mutual attestation if required, and the certificate request will only be sent if you need that mutual attestation, right?
Yes.
Okay. And did you have any thoughts? Do you currently have any thoughts about how the protocol would change for, let's say, if you were implementing it within a VM versus implementing it for a container within the VM? Does something change? Do they have separate identities, or at the protocol level, do you think there is something to consider?
I think the important thing here is that at least in our flavor of confidential containers, the containers that are allowed to run inside the VM are part of the VM identity. So we actually see from the measurements of the VM what containers will be allowed to run. So this is not running arbitrary containers that are then fetched from somewhere, but this is very clearly specified what is allowed to run, and this is part of our overall workload identity. So basically, our workload identity is the virtual machine measurements, and these include, by way of host data, a policy that allows containers to execute. So to answer your question, it does not matter. So our initializer runs as an init container. So it is also one of the allowed containers here. But it could run the same as a VM component and do this before running any containers.
Okay, thanks a lot.
Is this where you wanted to go?
Yeah, that's helpful. So I was just trying to see the difference that would be required, because our formalization was based on, for now, was based on the VMs. And I was trying to see how much difference I will have, let's say, if I go towards the container. That's very helpful. Thanks a lot for the presentation.
Yeah, if I may add, so we have the other this other project that at least Osama, I know you are familiar with, is Constellation, and there we actually do this ATLS. So I think it's mostly the same, and we do it between VMs.
Cool. Thanks a lot.
Zheng?
Okay. So my question actually is, so when I'm looking at this ATLS kind of like design, it seems to me like we want to try and contain basically the attestation verification generation of the ephemeral key all within one single TLS session. Now, initially, I thought this was supposed to be like used for like the public web, because in a decentralized kind of like environment, that would make sense. But just now you mentioned that the kind of like the point of this design is actually for it's for a data center setting. In that case, actually, does it make sense for us to actually try and cramp everything into one single like TLS session establishment, or rather should we kind of like break it up into multiple phases where, for example, I can establish within a data center, for example, a CA, servers that want to have a certificate can actually perform this protocol or this handshake with the server itself, and then the kind of like the data center CA would sign that this particular would issue basically a certificate to that particular instance, which it can use further on for all other communication. And then your verification would just end up being the standard TLS verification and mutual TLS verification too.
So I agree that for the use case that we have, we would not strictly need this protocol. What we could also do is we could just do an ephemeral TLS handshake, and we need to be careful that we that we at least need to verify that the certificate is actually like correct and so on. But basically an untrusted or like not CA verified TLS handshake, and then on the established TLS channel, get the metadata from the TLS connection state, and then do the attestation as custom RPCs back and forth, right? Definitely possible. We considered that to be to put too much potential for failure into the stack, because we wanted to use gRPC, and so in gRPC, so gRPC can just handle like multiple requests concurrently, right? And so after the TLS channel is established, a rogue attacker can just like send requests to the system before the actual attestation part is through. And what do you do then? So it's not like you can't solve this or it's impossible, but it just opens up potential for failure. And this is why we wanted to have like the established channel right away bound to the evidence that we expected, and then we can work on that channel and know that like we are so that everything is safe now. But it's not a hard requirement. I agree.
We're 5 minutes.
Thank you.
Sorry, we need to close the meeting now. Thanks very much, Marcus. Thanks everyone for the great questions and the nice discussion. And see you in a couple of weeks.
Thanks a lot.
Cheers. Bye-bye. Jim, if you're still there, do you want to take the next chair?
Yeah, I'm still here. Yeah, I can do that.
Thanks very much. Bye-bye. See you.
Yep. See you.